Thank you so much for inviting me to be part of this symposium. I've been listening to most of the talks. I'm coming to you from Sydney, so it is kind of late, so I may have missed out on some of the later ones. But today has been absolutely brilliant, and really there's nothing left for me to say. Everybody's said everything. I'm joking. This is a never-ending topic, and I think as the discussion so far has highlighted, there's just so much we don't understand, and the more AI uncovers for us, the more helpless we are as humans to make sense of, you know, what's really going on. Somehow philosophy and psychology and mathematics hasn't prepared us for this AI age very well at all. And I think that what I'm going to try and do is sort of go back to basics and really focus on that question about, you know, can an AI win a Nobel Prize? I don't think we're going to be going into, you know, general AI or consciousness or concepts in the human mind. I think we can approach it like you do when you build a robot. And, you know, you just want the robot to work, and you want the robot to do what it's supposed to do. And in this case, in the discussion today, we want an AI that can win the Nobel Prize. That's just you know, an engineering problem. Okay, let's see. So, you know, Herbert Simon, he won the Nobel Prize for Economics for decision making. It's absolutely fundamental. And I loved how decision-making kept coming up throughout this symposium. I mean, for example, just the discussion around search spaces and how AI can expand the human search space. I mean, I think the game of Go was used as the primary example. And I think that that's a really useful perspective, even though, you know, it has many flaws around participatory explanation, etc. But it is something that is sort of simple. It's a simple vehicle to kind of push and see how far we can kind of go with it. So I run the Magic Lab in the Australian AI Institute, and it's full of researchers, students, and robots. And I got started, well, certainly traditionally I'm an AI researcher. That's what I did my PhD on. And later I did a law degree because I realized that, you know, AI is touching everything. And the only thing that is going to shape it, okay, is law. And I think that, you know, there's a lot of discussion around ethics, but, you know, whose ethics? Ethics is pretty fuzzy. Law is something that can be enforced. And I feel that that is so much more important. Anyway, this is my team. It does include Steve Wozniak, co-founder of Apple. It's an extraordinary team. It has included senior engineers from NASA, and you know, but the main engine are just amazing students who are captivated by AI, who want to see, you know, what AI can do, and who like playing with technology, and in particular robots, and exploring that human-robot interaction frontier. So today I want to talk a little bit about human-AI interaction, human-robot interaction, AI itself, and then scientific discovery. I'm going to try not to go down any rabbit holes, and we can do that later. I just want to sort of try and, I mean, what I'll say will be in a way provocative through its simplicity, okay? But we know when you want to solve a problem, you've got to start simple. And that's what I'm going to sort of try and do. Let's see how we go. And maybe as I go through, you'll be able to put together a lot of the ideas that you've been exposed to so far. Because I feel like I've just been, you know, inundated with so many new ideas and new perspectives and new ways of looking at AI and scientific discovery. I just can't, I don't know I can put that together yet, all right? I feel like my mind has been deconstructed, and I'm sort of grappling to see how we can put it together such that we could go forward and actually do something in that direction. So my lab focuses on AI, machine learning, also reasoning and, explanation, knowledge representation. How do we represent knowledge in a computer? Social robotics and human-robot interaction. Social robots need not just, in problem-solving kinds of intelligence, but they need to be able to work with other technologies and people. People are just a technology, right? And social intelligence involves cooperation and getting other agents or other entities to do what you want them to do, or to get them to help you, right? So if I want, to get somebody's help on a regular basis, then, I've got to kind of generate value for them somehow. And that's what robots need to do as well. There's a famous experiment where a robot needed someone to open a door for it on a regular basis in order for the robot to complete its task. It couldn't open this particular door. It was a PR2. And it asked nearby humans. And initially the humans were super excited to help the robot. But, after a while, the humans sort of thought, the novelty had worn off, and they didn't really want to help the robot, okay? So robots in human-centered environments are going to need social skills, all right, that help them do what they need to do. And they might be trying to do something for you, a human, like, deliver your mail at the office or what have you. So I'm going to try and see if we can run this video. Let me know. Can you see anything?
Yes.
Yeah. Okay, cool. So here, I started out in robot soccer and Robocop. And this is a game in 2004, all right? These robots are playing autonomously. They are doing everything themselves. We wrote the code, we put it on the robots, and then look at that dive. Okay, so you saw the robots sort of running around, chasing the ball. You saw CMU make that incredible goalie dive. That was Manuela Veloz's team. And you may have heard everybody cheer when our robot, which was the blue robot, did a dodge. That was the first time a dodge had ever been seen at Robocop in the IBO League. The next year, everyone copied it. So that's the great thing about Robocop. Everybody goes forward together. But I just wanted to show that video because the idea of autonomy has come up quite a bit today. And I think it is important if, does this AI really deserve a Nobel Prize? Did it autonomously make a discovery? Now, it doesn't need to be all by itself. It can be in collaboration with humans. The Nobel Prize can be awarded to up to 3 people, all right? So, if AI could make a case that it made at least a 1/3 contribution, then yeah, it should get the Nobel Prize. So the robots playing soccer, that's 2004. The robots can pass, they can score goals. In fact, my team has the record for the number of goals scored in any game in that particular league. And it was, the score was 16-0. And the games only go for 20 minutes. That's 2 10-minute halves. So they were good, all right? They knew how to score goals and they could dodge, etc. Then I moved into social robotics, or a new social robotics league, started at Robocop, and I started a new team. And my team, we are software engineers. We're really AI researchers. And so we are interested in leagues that provide a robot or have a standard platform. That's why we got into the Sony IBO League, and that's why we used SoftBank's Peppers in the social league. And we came second for a couple of years, and last year we came first, and we won the world championship, and we're still the reigning champions. And you can see, I mean, in this competition, one robot does every task. It's at a home setting, so the robot goes on missions in somebody's home. And how many humans did we need to get this robot going? And winning that gold medal? My team was more than 20 humans, okay? So, you know, every sort of AI system does need a team of humans to make it work. But once we set our robot out into the competition, we had no idea what that robot would really do, all right? The robot is processing its own sensory data. Same with the robots on the soccer field. You know, there's no way that we could predict a game of soccer. We put the robots out there, and they play. They are making every decision. In fact, in robotics, the big question is for a robot always, what do I do next? Given what I know, given what I've just sensed, what's the best thing I can do right now? And so now let's sort of look at AI. It's a field that's been going for more than 50 years, and then sort of a subfield of AI is machine learning. And what is machine learning? It's basically, you know, building systems that can learn from data instead of hand-coded heuristics and rules. So that's big, okay? Because it means that the machine learning systems are not crafted by people to a large extent. I mean, they're crafted or shaped, let's say, by the data and how they process that data. And if there's any sort of stochastic process there, then, you know, it's sort of, I don't know, it makes it very difficult for people to anticipate what that system might do. And I think the other thing to note here is that there's a very big difference between prediction and explanation. And that is something that's come up quite a bit through this symposium as well. Now, deep learning was the big breakthrough, okay, as you all know. Why? Because basically, you know, traditional machine learning had plateaued. You know, the more data we were giving those traditional systems, their performance wasn't improving. And humans sort of reach a level of performance, and then it sort of, it doesn't increase very much. It sort of stays, you know, how can we sort of improve the performance of people? We're kind of limited. We're limited by our bodies and by our senses, and yeah. And along came deep learning. And the big game changer was that the more data we give deep learning algorithms, the better the performance. And as far as we can tell, that's going to continue, all right? So that's the big difference, all right? We haven't found the top of deep learning's capability, all right? And so for the purpose of today, you know, let's assume it's going to keep on going because we have no evidence that it's going to slow down or sort of plateau like traditional machine learning. I know that's a sort of an out there position, but, you know, we're talking about the Nobel Prize. Now, Andrew Ng, I think, put it best when he said that, you know, AI is like the new electricity. Electricity transformed society and business, everything, okay? It's been around for 100 years and it's still changing society and business and life as we know it. You know, consider, you know, well, robots, you know, they run on electricity, autonomous vehicles. It wasn't just a singularity event, okay? It continued. And AI today is very much in its early stages. And there's a long, long way to go. And it's already making massive impact. You know, it's outperforming humans in various ways. It's totally transforming industries that rely on, say, vision. And it sort of has potential to transform many, many more. It's fast, it's repeatable. And when it comes to science, repeatability is crucial. It can have broad impact and it's, you know, I mean, it's just reshaping everything. Even just Google and Facebook are reshaping everything. So I don't think that's controversial. It's multi-purpose. I mean, this sort of has a dark side as well, in the sense that AI is a dual purpose, can be used for good and for harm. But it can be used for empowering people. It is dangerous, harmful. It's been shown to be used for, you know, discriminating and surveilling, etc. but it's also uncovered so many flaws in human society. It's uncovered the bias that is now undeniable because it is provided, you know, these sort of mathematical models that tell us, you know, judges are biased. And if, you know, a human challenge a judge as being biased, and that's a really complicated process, but AI has sort of cut through a lot of the sort of obstacles that would stop us from identifying the bias and facing that bias. So I think that AI is doing good work, all right? Now, we saw, you know, why, you know, what's the game changer in deep learning? Oh, it's performance, yeah. But this performance in prediction has a problem in that the better our AI algorithms are at predicting, the weaker they are in explainability. And I mean, that's a kind of a fairly general position. And this particular slide is sort of something that DARPA came out with. And, you know, explainability has come up, so I think I'll just keep moving on. But I think it's an important relationship to consider, okay? Because ultimately we want high accuracy in prediction. We don't want AI making mistakes, but we also want that explainability so that when it does make a mistake, we know why. And also we want to know how we could, for example, improve the performance of, you know, specific data. For example, my bank loan is rejected. I want to know why it's rejected, make sure it's not a mistake. And then I also want to know, okay, how can I get it accepted? Nobel Prizes. So these are the areas, right? Now, remember, our task today is that we want to win a Nobel Prize. So for scientific discovery. So, you know, peace, it won't get us there. Literature won't get us there. Economics, maybe, but we've got to go after chemistry, physics, physiology, or medicine. Okay, that's if we want to get one. And Richard is a Nobel laureate. He won the Nobel Prize in physiology or medicine in 1993. And he's come up with sort of 10 kind of suggestions, rules, heuristics, whatever you like, how to win the Nobel Prize. And the first one is don't aim for it. So I'm going to ignore that one. You know, don't live your life, you know, trying to win a Nobel Prize. That's his big one. He's got 10 suggestions. I just picked out the ones that are relevant for today. And the first one is reveal the unexpected. Ask good questions, you know, use innovative methods to answer them, look for those unexpected results, and try and, you know, find something that's that can't be explained with traditional models. Okay. So, you know, what can sort of uncover patterns best? Well, AI, okay? Now, does it have to ask good questions? Maybe not. That's what humans have to do. Humans have to use causal models to, because we can't really process vast amounts of data quickly, okay? We've got to kind of concisely summarize that data in causal models, because that helps us sort of go forward and maybe ask these good questions that might win us a Nobel Prize. So, you know, I think that there are different pathways, and I don't think AI has to go the way of the human. As we discovered in the last talk, you know, the human brain is very, very different to a neural network. And so, you know, how it makes discoveries will be different. Okay, so to me, it's more about how do we measure the contribution of AI to, you know, an amazing, unexpected result. Okay. One way to, or an areas to focus in is, you know, trying to find where current science is wrong. All right. Try and, Einstein's Nobel Prize for the photoelectric effect is a good example of that, because, is light a particle or a wave? Well, okay, the data came in and said, oh, it's a wave, right? And then the photoelectric effect kind of challenged that. And then there were a few theories going around, and then Einstein sort of solved that problem. And then somebody else later collected the data that supported it. And that's very, very common. And I feel like, from what we know about AI now, we know that, autonomy is hard. Writing rules for scientific discovery is going to be hard. Getting those pipelines are going to be hard. But finding patterns in data is going to be easy. And AI is going to be much better at that than people. So that's probably where we can get some low-lying fruit with AI. Now, we can only have 2 human collaborators. We can't have any more, right? Because there's only three laureates in each of the areas, okay, each year. So we're going to have to be super selective. Very few Nobel Prize winners have won a second one, only 4 over all of this time. So we should probably avoid those kinds of people. But it's good to hang out in their labs and try and learn the kinds of questions that they ask, and the methods they use, and the practices that they execute, all right, in their lab. So you go there, we learn all of that, and then we sort of go out on our own with maybe 2 humans who are super smart. And then let's work in biology. Why? Because there are 2 categories. There's the physiology in medicine and chemistry. And so half the chemistry prizes actually go to biology, all right? So I think there are a few nuggets in here that we can use to help AI win a Nobel Prize. Of course, we are going to have to do some fast talking to get the Nobel Prize Committee in Sweden to sort of agree that the AI is alive. But when you watch those robots play soccer, they feel alive. And that was 2004. Okay, so, what are the sorts of questions that we might ask? Say in physics. I'm going to have to speed up here. How old is the universe? Well, we know actually to a high degree of accuracy, plus or minus 10 million years. So, that question's already been more or less solved. I mean, if getting more accuracy is good, but that's not going to be great. What came before the Big Bang? That's the question. That's what we want to know. What happened, 15, 16, 20 billion. Actually, sorry, that should be a B. That should be 13 billion. Sorry about that. What's inside a black hole? We don't know. I think if we could get a lot of data, we could write eventually write an AI algorithm that can help us figure out what's inside a black hole. And I actually don't see this question being answered without AI. What is dark matter? Similarly, and what is dark energy? What's making the universe actually expand, and why is it changing its acceleration? AI is transforming all fields of science, and it's really accelerating chemistry in 6 basic ways. I've actually lost track of time. Somebody wants to tell me how much I have left. Okay. So I think I'm probably well behind. Okay, and then in terms of what can AI do with data, right? So modeling or even determining the human genome has really been an incredible watershed moment and a massive game changer in science. DNA is the rubric of life, and so if you can decode it, then wow, you can really use all of those insights and test things and do things in a whole new way, and that is really transforming science, including how we see relationships between different species and what have you. And a group of people have used, DNA that nobody even cared about to find the cause of autism, which I think is just absolutely incredible. So now we know what causes autism from, a DNA perspective. And Google has created AI that can detect lung cancer better than doctors. And I mean, there's quite a lot of AI out there that can outperform doctors and experts in specific kinds of areas. So there's huge excitement there. So I just picked these two because they're kind of fairly recent, and these applications getting more and more sophisticated. But notice they are at the data end. I mean, this is low-lying fruit. So can AI win a Nobel Prize? Well, I think it's going to have to come up with, a new theory, new models for something super important. And so, I look for hints of, how good, what's the capability of AI? We know it's in its infancy now, but, what would suggest that AI might one day win a Nobel Prize? And I think the fact that it can solve, university level mathematical problems, calculus, and, university level calculus today is very similar to the kind of mathematics that Einstein had, all right? And that's pretty impressive, okay? We take it for granted, and we have a lot of tools to help us, even, scientific calculators can do graphs and stuff like that. But, if AI can really solve university level calculus, that's telling us that it can, do more than just, find zebras in photographs. And the other big one is the three-body problem. This is an open problem in physics. There is no analytical solution as such, but, we use simulations, okay? And, the AI just totally trumps what any human can really do with a sort of computational model, all right? It can predict where these bodies will be, and the three-body problem is, if you don't know, if you know the place, the location, and the velocity of three bodies, then what you want to do is predict where they're going to be after a certain length of time. And those three bodies might be as they were when this problem was first postulated: the Earth, the Sun, and the Moon, just for, that's needed for navigation around the Earth. And, they're all affected by gravity. And it turns out to be a very, very difficult problem. So AI has more or less cracked this. It can solve this problem very, very quickly. And it's already moved on to the four-body problem and the five-body problem. Like, no human was really ready for that, okay? And then, and then there's really, AI is just so much better than humans. Humans aren't even in the game when it comes to finding patterns in very large volumes of data, okay? And we get a bonus, right? Repeatability. Science is all about repeatability. It's the foundation of science, right? In fact, early on in the Nobel Prize, someone was given a Nobel Prize. They claimed they had a cure for cancer, and it turned out to be wrong. And so that's why the Nobel Prize is not given immediately. They wait for a bit of time to make sure that no one can show that the results, whatever they are incorrect. So repeatability is super important, and you get that for free essentially with AI. No, it is a black box, but we can make that black box produce the same output from the same input. All right. So while someone may say, well, I can't really, if it's, I may not get so much comfort from that. But I think that it's still a way forward, because at least the software is human understandable, And as somebody pointed out earlier, there are elements of a neural net that we do understand. Okay, so, here's my sort of summary slide. A is transforming the way we do science. The questions we can pose are now different, and just, sort of enabling different questions allows us to sort of dig in different places and learn new things that we wouldn't otherwise. That alone should get a Nobel Prize. And it can answer questions that cannot be answered without it. That's pretty telling, isn't it? People say, if Einstein didn't come up with relativity, I know Einstein didn't get the Nobel Prize for relativity, but it did help, all right? Then someone else would have, right? If Einstein didn't come up with it, somebody else would have. Same with evolution. If Darwin didn't come up with evolution, somebody else would have, right? It was just going to take longer since these individuals had the insight at that time. It was good. But, AI is allowing us to ask and answer questions that no human can come up with. That's way better than, Einstein, okay? And, then you always have this question, is it the AI or is it the programmer? And I think this is where we should focus, okay? How are we going to measure contribution? Because that's all it is. Now, no one's going to say Galileo's telescope should be given a Nobel Prize. I mean, it really is just a simple tool. It's not doing any processing as such. It's amplifying a sense that we already have. So amplifying senses, or even translating a sense into something, visualizing something for a human is probably, not worth a Nobel Prize. But actually collecting and processing data beyond, our sort of sensory realm, I think is maybe worth it. Now, we can argue, well, does that include a radio telescope? No, it doesn't, all right? Because the processing here, like if the processing is sort of not rules that people have written down or encoded, and that we don't really even know what they are, okay, which is what machine learning is all about, then yeah, I think there's a case can be made. Let's just put it that way. And, did what the AI do, was it such that a human couldn't do, and how autonomous was it? Did the AI do everything, the whole pipeline? Or, what was the contribution? And could the discovery, whatever it was, be made without the AI? That's kind of pretty telling. And by the way, what did the humans do? Did they collect the data? Did they source it? Did they create it? Did they just train the AI? Did they do the encoding? Was there any real sort of intellectual advancement required in what the human did? Or were they just a slave to the AI? And, what's the level of novelty when it comes to the AI? And we can use a search-based search, I think is a very good idea. And, were they beyond what humans could do? And in terms of the decision-making, the robot team that you saw earlier runs a cognitive architecture. And what happens is that the processes within the robot compete for the robot hardware attention. And so it's sort of, much like a human, right? It's actually a bio-inspired architecture. And I feel like, once you're getting into the robot really taking control of its own decision-making, then, or the AI, I should say, then I think, again, you can kind of make a case. So I feel like AI, it's changing science. It's got to change the way we reward science. And I really feel like the Nobel Prize is almost past its use-by date. It's going to be disrupted. I think the work on the Nobel Turing Challenge is highlighting the need for a new way to appraise and reward scientific advancement, okay? Especially when, you know, mathematicians and computer scientists, we're just out of contention, completely out of contention. So now it's time for questions.
That was great. Was so totally fascinated by the talk, by your lab pictures, by the Robocop video that you shared. I literally called in my daughter to show her the pictures, and she was like, "Show me more later." She was totally fascinated what she sees in her cartoons, and you can see actually somebody working on those.
Yeah. Well, look, one of the reasons I kind of got into robotics is because they're visible, all right? And they're sort of, you can touch them and you can see what they're doing. And I love Robocop. It's extraordinary initiative, okay? And I think it's also responsible for a lot of advances because of the model. You know, we compete and then we share. We share ideas, we share algorithms, we can actually share code. And, you know, that's why we've actually even got robots out there today, because before Robocop, people who, worked on vision just worked with, cameras, and those working on locomotion were just kind of working on legs and wheels and things. You know, having integrated robots were, they weren't very prevalent. And only the top universities, Stanford and others, places, in Australia, just really didn't have the ability to do that. And actually the Sony Ivo totally transformed robotics as well, because it was the first, commercially available, mass-produced robot that had sensors in and that was, sort of inexpensive. Yeah. Anyway, do we have some questions?
Yeah, we have two questions. So first question is, I feel like I'm very limited to having a human perspective. So if AI does discover something, humans may not necessarily be able to make sense of it. Would you agree? And what are your thoughts on it?
Yeah, and I think this is sort of the scary thing, and it's already happening, right? We've got these black boxes, and we don't really know what they're discovering, and we could very likely be discounting things, right? Just because we don't understand it, that doesn't mean it's not great, So I think that I don't really know how to approach this, because we are very limited by our senses, and we're learning all the time by, cognitive bias. I mean, we have more than 100 cognitive bias in our heads, and I think it's very hard for us to get out of our own little world, and even within disciplines. So, and I do see this quite a lot, because, you read out all of the areas. I started in a business school. In fact, I started my first robot soccer team in a business school. And I see a lot of kind of, barriers, not just in communication, but in ways of thinking and dismissing good ideas. And we've all seen where, the leader in a field has dismissed a sort of a naive question, or someone's idea who, is maybe just starting their PhD. And they just get dismissed when actually that idea could be really good, right? And so and that's another reason why I work in entrepreneurship, because the way to sort of kind of navigate this is to just test your ideas quickly, as soon as possible, right? Before someone can kill them, and try and sort of validate your ideas and identify your biggest risk first. Test your biggest risk. Once you've tested that, go to the next one, or, get that feedback and just keep going forward, because nobody's really got the answers anymore. And everything's been sort of turned upside down with disruptive technology, and AI is really challenging everything, including the law. Okay. So, and I feel like, okay, Nobel Prizes being challenged in terms of its use. And even things like discrimination law are going to have to change, because you can't say, oh, we can't have AI discriminating, because everything is about discrimination. Societies run on discrimination. So it's more about what discrimination can we tolerate, what's going to be good for society, and shaping that. And yeah, I have many more questions than I have answers.
Sure. Yeah. So there are more questions. In the interest of time, maybe we'll move forward, and then if you're around, you can answer those questions offline. Yep. And you should also go over the chat. There has been so many comments about your talk, and So quickly to move forward, I guess Dr. Williams' talk, along with bringing the perspectives on the places where AI can overcome the challenges that humans are facing. What are the places where AI can do better? Also introduced to the concept of novelty, that there could be things which AI can really ask. Ask those questions which humans have not asked so far. Going forward in the direction of novelty, Dave, would you like to share your thoughts here?
Yeah, I think we've touched on this a few times between a number of talks thus far over the last couple of days. Yeah. And we are clearly grappling with really core issues about how we tick and what it takes to actually not just go through the mechanics of thought or the processes or models around them. Of course, every good scientist needs classification, but it's these emergent things that come out either as side effect or, truly happen, in terms of like novel creations, which we're starting to turn to think about. And someone who's going to take us through that is our next speaker, Dr. Vikram Javal,